So we want to explore what will happen if we change some of the conditions around a compound interest question. So we want to explore first what will happen if we change the interest rate at which the investment is going into. So if we take a look at our first situation, it says here that Katie invests $8,000 in a mutual fund that has historically paid 8.9% per year compounded annually. And how much is it worth then after 5 years? So if she invests $8,000, that's the principal. We want to know how much it's worth after 5 years. That means we're looking for its final amount. We know that the I value, again, the interest rate, is expressed as a decimal. Okay, so the I value is going to be 0.089 divided by the number of compounding periods per year. And since it's compounded annually, that means it's compounded one time per year. So just 0.089. And how much is it worth after 5 years? So 5 times 1. 5 times 1 is equal to 5 compounding periods per year. So if we plug this into our compound interest formula, A is equal to P times 1 plus I to the exponent n. So if I solve this, or substitute in rather my values for the variables I know, 8, 9 to the exponent 5, and I can simplify that by doing the addition that's inside of the brackets. So I get 1.0.089 all raised to the exponent 5. So if I calculate this, then I get 1.089 to the exponent 5 times 8,000. So in 5 years, it should be worth $12,252.63. Okay, which is a pretty nice rate of return. Now, what happens if we change this around? So if we double the interest rate, if we increase the interest rate, what's going to happen to our final value? Is it going to go up or is it going to go down? So let's figure out all other conditions being the same, but this time we're going to double the interest rate. So still don't know how much we're going to get. We know the starting amount is $5,000. This time we're going to double the interest rate. So if we double our interest rate, we're going to go from 8.9% to, let's see, if I double that, 8.9 times 2, that's going to give me 17.8%. So 17.8% as a decimal, 0.178 divided by 1 because it's still compounded annually, and my n value is still going to be 5. So if I plug this in, I'm going to get 8,000 times 1.178 to the exponent 5. So in this case, if I do 1.178 to the exponent 5 times 8,000, I get a total amount of $18,147 and approximately 49 cents. Okay, so the impact of doubling the interest rate, while it doesn't necessarily double the final amount, it does more than double the interest earned. Okay, and so if we compare it the first time, we invested $8,000. So if I want to figure out how much interest was earned, I subtract $8,000 from each of these. So 12,252.63 minus the 8,000 that we originally had. Okay, so in the first situation, $4,252.63 was the interest that was earned. And in the second situation, we actually got a little bit more. So we got $10,147.49 was the interest. So by doubling the interest rate, we actually more than doubled the amount of interest that we earned. Okay, so obviously increasing the interest rate, okay, increase the amount of interest we earned. So what was the impact of doubling the interest rate? We made more money. Okay, so in simple terms, we made more money. Okay. Did it double the final interest rate, the final amount, or the interest earned? Uh, it doubled the final interest earned. Actually, it did more than that. Doubled interest earned. So it did not double the final amount, but it did double the amount of interest that we earned. Okay, so that's the first part of our investigation.